Welcome to CleanTitans. Today, we're honored to have Jason Huang, founder and CEO of TS Conductor. He has a distinguished background in materials and engineering. Jason, welcome to CleanTitans. Please briefly introduce yourself and tell us about your journey to transforming the grids of the world.
Thank you very much, Ali. I appreciate the opportunity to be in this podcast. My background, I'm a material scientist by training, and I do have a PhD in material science and engineering. However, my focus for the past decade and also going forward is in the power grid, offering a better conductor solution for our power grid. Many people take electricity for granted and obviously take the grid for granted. And what they don't realize is our power grid, it is still featuring a conductor technology that was developed in 1908. And that is why we have bottlenecks in our power grid. And that is, how do I put it, how old-fashioned the technology is. And we're into the 21st century with a multitude of challenges that they all boil down to the power grid. We need significantly more capacity power grid to whether it is connecting all the renewable generations or meeting the load growth, in particular short term from AI data center, manufacturing, and all of these boil down to, do we have the ability to deliver electron where it's generated to where it is needed the most? And that's really where we're focused on solving the problem.
Your company, TS Conductor, is tackling a fundamental challenge in the energy transition, modernizing our power grids. You stated that T&D technology hasn't significantly changed in more than a century. Could you elaborate on why this century-old infrastructure is now a critical bottleneck for the clean energy revolution, and what prompted you to found TS Conductor to address this?
Yeah, I should calibrate that commentary a bit because others will have problems saying the grid hasn't changed in the past 100 some years. I'm talking about the wire that does bulk of the work, power grid in moving electrons. That has not changed in the past 100 years. And without addressing the wire technology, you're not going to move more electrons in the wires. And you could also have undergrounds, but majority of our power lines are still above the ground. It's called overhead lines. And if you use the same technology, you're always going to be limited by that technology. And let me elaborate a bit more on this century-old conductor technology called ACSR. The ACSR is aluminum conductor, steel reinforced. It was developed and commercialized around 1908 at the time by combining high strength steel with hard aluminum. You might ask, why not the more conductive aluminum for a conductor, right? Well, the steel at the time was not quite high strength enough. So the conductor need the strength contribution from the hard aluminum types. And that hard aluminum type give you strength. However, it also brings in temperature limit because when we have temperatures above 93 degrees in the conductor, the aluminum changes from hard to soft over time. And that's why we cannot exceed that temperature limit. And that's really what fundamentally limits our capacity. And there's also an additional constraint there, which is the steel wire inside. It does somewhat sag when you go to approach that temperature limit. And so the sagging issue also is something the transmission line designers had to take into consideration. But the bottleneck issue is really related to capacity, related to the temperature limit in the conductor itself. And so to address that issue, I almost have to tell you the whole story of conductor technology evolution in the past 100 years, and why it led to us where we are with TS innovation, right? So I mentioned about the temperature constraint in the ACSR conductor, And to address that temperature limit so that you have more capacity, we fast forward to the 1970s. That's when our steel industry was able to offer stronger steel. Now, with the stronger steel, you now can combine a near aluminum with this group, with the new higher strength steel. That's why ACSS conductor was born in the 1970s. And these conductors are called aluminum conductor steel supported. And they can go to high temperature for the high capacity because the aluminum now is able to go to high temperature, and the steel with some proper protective arrangement can also support high temperature. So now you have a conductor that can support high temperature operation, which means high capacity as well. The challenge though is the steel expands when hot. That creates excessive sagging problem. And with the sag, if you were to do reconductoring simply, you needed more capacity, you swap the conductors out. Let's say you swap the ACSR out with ACSS conductor to get more capacity, but the wire is going to sag with temperature. When the temperature goes up, you have to raise those tower height sufficiently to allow you to maintain ground clearance. That significantly increases project costs, and also you need a lot longer outage time to work on those towers. And if you were to do new transmission lines with ACSS conductor, it means because of the sag, you have to shorten the distance between the towers to manage the sag. And that increased number of structures is going to significantly drive the project capex cost. So it is not an ideal situation. And to solve this sagging issue associated with steel, advanced conductors started to emerge in the 1990s. And we basically are deploying composite material with lower thermal expansion. Unlike the steel in the traditional conductors, I would consider ACSR and ACSS both as traditional conductors because they use steel wire in the strength member. With the composite material with lower thermal expansion, now you do have a conductor that can go to high temperature and have the sagging and temperature increase properly managed. The unfortunate part is these group of advanced conductors are known to be delicate, difficult to work with, easy to break with longevity concerns, and they're also expensive. So our industry has had these poor experience that it has not really taken root and replaced the traditional conductors. And this is why the TS conductor was deployed and commercialized around 2016. And I got involved in the 2018 timeframe when I recognized the merit of this technology. We basically went all in. I acquired the technology and established TS Conductor Corporation. Why TS is able to solve that problem? Well, it is a material science story. And by the way, when I mentioned it to you about the evolution from ACSR to ACSS to the first generation advanced conductor, it's a problem solving journey from a material science perspective. The first problem was about, well, there's the temperature limiting ACSR. How are you going to address that temperature limit? And then you have ACSS came along, it solved the temperature limit, but it got the thermal sag issue. So then the first generation advanced conductor came along to solve that thermal sag issue. But it brought in these new issues of too delicate, difficult to work with, easy to break. So the TS foundational sort of purpose is to solve that delicate, difficult to work with, easy to break issue in the first generation advanced conductor. So we leverage carbon fiber composite as well, but we have an effective protection mechanism for the carbon fiber composite that has never been prior. And with the TS configuration, what we have is we have our composite for pre-tension, and that pre-tension was preserved with the aluminum encapsulation. And that pre-tension is important for the fundamental reason that composite material, the way it is made for a cable application or conductor application, such a way that it is exceptional in tension, pour the tension. Imagine this is a cable. You pour them in tension, it is strong. It's fiber dominated property. But if I were to squeeze it from the ends, that is compression. And when you do compressions, the compression strength in the material is a matrix material dominated. Here, it's the epoxy material. And when the conductor is bent in the curvature, the underside in the bending is in compression. The upper side is stretched, is in tension. It is the underside that will break prematurely. And that's why the first generation advanced conductor is very easy to break. So what we have done is we built in pre-tension in there so that the linemen that are working with our product, now they have that robustness because it does not break on the compression side anymore. And it basically have that fundamental limit or handicap being completely designed out in the product design approach. And by the way, this aluminum encapsulation also eliminated the degradation mechanisms associated with the composite conductor as well, because we eliminated the moisture, the oxygen, the UVs, and the ozones that all could potentially damage the composite core, especially the polymer matrix. So we also design in longevity into the product. And lastly, that aluminum layer around the carbon fiber composite makes the product compatible with our traditional way of doing conductor installation and the maintenance. And so the lineman who has experience working with traditional conductor can go directly play and work with TS Conductor. No new tools, no new equipment, no new methodology, and no new trainings. Unlike the first generation advanced conductor, that you have to go through rigorous training, get certified, because those products require perfection from line crew, which is just not realistic. So again, it is a problem solving journey. You're solving a problem. Now you finally have a conductor that deliver the high capacity, and it's got the workability in the field because it's safe and easy to work with. And at the same time, it's also more affordable compared to the traditional conductor approach from a project CapEx cost perspective.
Excellent. Many people think primarily about renewable energy generation, solar panels, wind turbines, when they consider clean energy. Why is the transmission and distribution system equally, if not more crucial, for achieving our decarbonization goals?
Well, there are several reasons for it. One, where we generate these renewable electrons, whether it's solar or wind, they are often in no man's place because they're a hostile environment. No one wants to live there, right? Where we consume electricity is in the cities, in the factories, in the hospitals, or data centers. And so you have to have the ability to move the electron from where it's generated to where it's consumed. This is really where the power grid comes in. And the second point is the renewable power, they need to be dispatchable as well. And if the grid cannot accommodate these renewable generation, they're of limited use. And if you have the grid with very limited capacity, you're going to have a problem in terms of getting those renewables connected to the grid. This is why we have such a massive backlog of these renewable generation projects that they cannot get connected to the grid because we simply do not have the capacity to accommodate. And I would further elaborate that if we have unlimited capacity or abundance in the transmission capacity, you could conceive a situation where you have wind turbines that are turning during the middle of the night. And in today's environment, there's not much of a load demand for it. You basically have to let those turbines run empty, right? There's sometimes so-called negative electricity price because there's no demand, there's only generation. However, If we connect the electrolyzers to the grid, it could be anywhere in the grid. If the grid has abundance in capacity, then you can turn now wasted electricity from wind turbines to effective use, make green hydrogens anywhere that's connected to the grid at virtually no electricity cost to it. And when the grid is expecting or needing more capacity, you could also turn those hydrogen back into electrons and make money. So you basically are able, from a holistic perspective, make the whole system work better for society, for humanity.
Could you give us a vivid picture of what operating a 21st century grid with 20th century wires actually looks like in terms of limitations, inefficiencies, or risks?
Yeah, the efficiency is easy to explain because with TS Conductor, for example, with the same structure, we can give you as much as 3 times capacity, and it can be a larger conductor with surface optimizations that will give you 3x capacity, by the way, on the same structure. And it also,
Mhm.
at the same time, reduce line loss by as much as 50%. And
Wow.
when you have less loss, Ali, it helps the whole system to have a lower cost because the loss is something that you have to make up, right? But on the other aspect that you mentioned about, you don't have to think very far. Just a month or two ago, we had the blackout in Portugal and Spain in Europe. Spain at the time, over 70% or more of the electricity are from renewable generations. And you had the massive blackout. And I don't think the investigation is complete yet. But if you do not have abundance in capacity, if you just trying to shove as much renewables onto the current system, it's not going to give you reliability in the grid that we all come to expect. Whenever you go home, you switch the light is on, or your hospital needs the electricity at all times, and it's not going to happen. And that kind of gives you a pretty vivid and a very recent memory. If we do not have an adequate grid, we're not going to have energy transitions.
Well, 50% efficiency improvement, that's significant because there's huge power losses on the grid. 72%, I thought I read some time
Uh,
ago.
well, they're normally much less. I think I read a number from US DOE. This is actually old data that the loss is about 8.3% on average. But even that, it's massive. And if you can reduce half of that, it is 4%.
That's money in the bank.
Oh, absolutely. We're talking about many billions of dollars worth.
The whole system, you don't need to build as much power storage or power generation if you can increase the capacity of the lines by decrease the line loss by 50%, right? You
But
need a
the
smaller system.
Yes, but the real irony here is we have zero mechanisms to incentivize our utility, which is the grid owner, in terms of making the grid more efficient. Because for them, the business model is about capex investment and make money on the investment. But in terms of whether the grid is becoming more efficient or not, that is not a metric. And if we look at it from a holistic perspective, if you are able to get more capacity at the same time having the grid more efficient, it's going to minimize cost for everyone. And I think this kind of begs the question in terms of regulatory side, a policy making side, that we are way behind when you look at efficiency all around us. Even our kitchen appliances, right? We sometimes get incentives from our utility company to use more efficient refrigerators and the dishwashers or microwaves, but we don't have incentives for the utility themselves to use more efficient conductor, which is something that should be fixed.
And that distribution cost is becoming larger and larger share of people's bills.
That is very true. And it doesn't have to be the case as we have more load that are coming. I think the per unit price, kilowatt hour electricity price should not necessarily increase if we can leverage the efficiencies and if we are also leveraging conductors like TS to drive the capex cost lower as well.
TS Conductor offers award-winning high-efficiency conductors. Can you break down in relatively accessible terms what makes your technology different from traditional ACS or ACSS conductors? What are the core material science innovations behind TS
Yeah.
Conductor?
So I'm going to speak with my material scientist hat on. In the TS configuration, we have carbon fiber composite core, and then we have the most conductive type of aluminum. It's called a neodymium aluminum, highest purity possible in that category. And in the composite core, we have a carbon fiber composite that is only 20% of the weight of steel. So you now have the possibility to integrate as much aluminum into the conductor and without creating a weight penalty in the overall conductor weight. Because a heavier conductor is going to require a lot taller structure and beefier structure, and that's going to cost more money in terms of the transmission infrastructure. So if you are able to leverage the existing infrastructure, but having a conductor that has significantly more aluminum in it without increasing conductor weight, then you are already a significant step ahead. And number two, in the annealed aluminum, the strength of these annealed aluminum is not there. And the reason we do not need the strength contribution from the annealed aluminum is because the carbon fiber composite core is twice the strength of steel. So we don't need strength contributions from annealed aluminum, even though we're using all annealed aluminum in our conductor configuration. And so when you combine these two factors together, you are basically using the maximum amount of aluminum that you can, and also it's the most conductive type of aluminum, the annealed aluminum. Now you will have a conductor that gives you the lowest possible resistance. Now, if you pass the same current to it, the conductor is going to run cooler. And when the conductor runs cooler, the resistance associated with that lower temperature is also less. So your net resistance in the conductor will be less. So when we say line loss, this is really just a high school physics. It's a resistance heating. So it's I squared times R. And when your R is, let's say, 50% or less compared to the ACSR conductors, that's why you have the significantly lower line loss as well.
You boast impressive metrics, 3x ampacity, cutting line losses by as much as 50%, as nearly eliminating sag. Let's unpack these. How do these improvements directly translate into benefits for grid operators and ultimately energy consumers?
Yeah, I think I'm going to set aside the line loss a bit because our current regulatory framework do not provide a mechanism for the utilities to pay much attention to it. And so on the capacity and the low sag aspect, when utilities are doing CapEx projects, it's all about we need more transmission capacity. Or when I use transmission, it also includes distribution. It's about the grid capacity. And if your conductor is giving you that capacity that you need, then you don't have to build as many new lines. And if the line is not saggy, when we say virtually no sag, it was referring to when the temperature goes up, does the conductor sag further? And this is compared to the traditional conductors. The TS conductor do not, because the carbon fiber composite, the unique attribute of that product is it has virtually no thermal expansion. And the three things that is unique in the carbon fiber composite, and these three things are all sought after properties in the conductor: high strength, lightweight, zero or very low CTE. We have that uniquely in carbon fiber composite. And so when you have that low sag or low thermal expansion, low sag situation, then you don't have to build your structures as tall because these structures, the taller structures, are going to cost you money. Now, with the TS conductor being low sag, you could actually bring the towers further apart, which means you're building the lines with fewer structures or use shorter structures as well. And that will cost less because the foundation is simpler and your tower or the pole itself is simpler as well. So all of this boils down to lower project capex and do it faster as well, while you are able to maximize the possible capacity out of that transmission or distribution corridor.
The reduction of line losses by up to 50% is huge from an efficiency and emissions perspective. Can you quantify the potential climate impact if this technology were widely adopted across existing grids?
Yeah, at one time I did analysis and just using the DOE number that if we were able to, let's say, use TS conductor to replace the wires around the world without looking at how the future load growth might be, just looking at today's environment, the sheer reduction in compensatory generation to make up for the loss alone would result in about 500 million ton of greenhouse gas emission related to what we call compensatory generation alone. So that's the kind of benefit that you can expect.
You mentioned solving problems associated with previous generation of advanced conductors, specifically ease of use with existing tools and techniques. How significant is this drop in capability for accelerating adoption by utilities?
This is huge. Our industry is notoriously conservative, slow to change, risk averse, and for the right reasons. The grid need to be reliable. And also for anyone that works in power lines, safety is always number one. And the linemen that are working with conductors, if you make it challenging, complex, difficult in terms of adopting a new technology into their hands, you can anticipate the reactions. And especially a product like conductor that people's lives are on the line. You have a product that is too delicate, that require perfection from line crew, it's just not pragmatic. It's just not realistic. So it is foundationally different, important that we solve that problem. And this is precisely why TS technology is embraced by our utility customers, by line crew in particular. And we have quite a few video clips in our website. People can check that out. That is really refreshing, by the way. And used to be involved in the first generation advanced conductor, and I know firsthand experience how difficult it is when you have a product that are too delicate, difficult to work with, easy to break, just not like it. Because when something happens, they get blamed for. And if something really were to happen, their lives are at risk as well. And that is how serious it is. We're talking about electricity.
TS Conductor aims to accelerate grid modernization and decarbonization and enable better renewable integration. How specifically does your technology facilitate an integration of more renewable energy sources, especially intermittent ones like solar, wind, onto the grid?
Yeah, would love to address that, but I also wanted to blend in much more immediate issue in terms of load growth, because people could say, well, generation, connecting energy transitions, that's a long-term thing, right? Right now, we have a real on our hand. That is all the AI data center. How do we take care of that, right? In a utility perspective, they need more bandwidth. They need more capacity in their system. And the capacity is constrained by the wire itself. Unless you do something about the wire, you're not going to fix the problem. And you have a solution in TS that is not only affordable, that is not only workable from alignment perspective, it is also going to deliver that 2 to 3x capacity that we all project that in another 20 years, the grid need to be 2 times or 3 times the size of our current capacity. And you can already get there if you deploy TS solution now. And this is really what's at stake. So if we do that, you not only solve the short-term problem of addressing load demand from AIs in the data center, and this is accelerating. In the long term, you're also able to help with energy transition. You're helping with these renewable generations to quickly connect to the grid because the developers, even though they're developing wind and the solar generations, they're not going to be able to make money until they're connected to the grid. So it is going to help everyone if the right conductor technology is deployed in our grid. And I would add one more point that often people don't think about this. When we design new transmission lines, and we design it now for probably 50 years or more, and these conductor technologies that we're talking about, they're designed for another 50 years. So if you were to deploy TS solution today, you get the benefit for the next 50 years. Future-proof capacity, up to 50% reduction in line loss, and all these attributes. There's also benefit in terms of resiliency against extreme weathers. All these benefits, you get it from day one. But if you continue to do the same thing, the same old way, like deploying the century-old conductor technology, you're going to be stuck with that conductor for another 50 plus years. And these are decisions that has consequences.
Absolutely. We need to speed up that transition. We're seeing a massive increase in electricity demand due to EVs, heat pumps, and overall electrification. The number of smart devices and screens is exploding in our homes. How does TS Conductor directly support the Electrify Everything movement and handle these new loads without requiring entirely new transmission corridors?
Right. The bottom line with all these electrification of everything is you're going to have greater need for electricity. It consume about, I think, 2/3 of the energy in the form of electricity. And there's other type of, I forgot it was 2/3 or 1/3. I heard, I think it's Elon Musk who coined that phrase. And as we migrate energy consumption to the form of electricity, the expectation and the burden on the power grid is going to become enormous. And this is why people are talking about the grid need to be twice or 3 times the size compared to where we are today. And what does it mean? Well, if the grid is 2 times or 3 times, it means it has the ability to deliver 3 times electricity compared to what we had before. And we have increasingly difficult time to build new lines because getting rights of way and all the permits associated with it is difficult. So you wanted to get as much capacity out of the existing corridors. And that's where you could leverage technology like TS, much as, for example, 3 times capacity. And on the same structure that's in the right of way, that is, in my view, the quickest, most economical, and most sensible thing to do in terms of transforming the grid to the EVs, the pumps, and all of that into in the form of electricity.
Beyond renewable integration, how does a more robust grid infrastructure enabled by TS Conductor contribute to grid reliability and resilience in the face of extreme weather events and other disruptions?
Yeah, Ali, that's a great question. When you look at the extreme weathers, you could look at three categories: the ice, hurricane, wildfire. And let me elaborate on each and how TS can help. In terms of wildfire, our conductor is already high temperature capable and it is sag proof. So, what does that mean? Well, imagine you have a transmission line and a wildfire is passing through under the power line. If you have a traditional conductor like ACSR, and most likely those are going to be ACSR, what when you have wildfire happening right below the power line? The heat generated will cause the ACSR wires to sag, and that will draw the wires further close to the fire. And the heat could be hot enough to melt the metals. And if these wires did survive, you have a situation where we talked about the hard aluminum in ACSR conductor. That hard aluminum is already converted into a near aluminum. It lost all the strength from the aluminum contribution. So you have to go back, replace those wires. With TS, you have a very different scenario where our conductor does not sag, even though your temperature is increasing from the wildfire right below. Why? Because the conductor with carbon composite core does not have that thermal sag issue. And the heat is not affecting the conductor itself because we already use annealed aluminum. So it's going to survive these extreme situations a lot better than the traditional transmission lines. On the hurricane wind conditions, especially in the coastal area, our conductor feature what we call a trapezoidal aluminum layer on the surface. It makes a smoother surface, and there's wind tunnel testings by conductor companies in the past that they concluded that you can reduce wind drag force by as much as 40%. So what does it mean? Well, on the same size conductor, if it's a TS conductor versus ACSR, TS conductor under the same wind condition would have 40% less wind load onto the conductor, and that translates into equally retention towers as well. So you're going to make these towers and the transmission lines survive better in these hurricane wind conditions. And by the way, the hurricane wind is becoming more and more intense, and this will become important as well. Ice. First off, our conductor, unlike the first generation advanced conductor, which feature glass fiber in it, that makes the modulus of the conductor low, which is very saggy when you have ice accumulation on the conductor. We do not use fiberglass. That's why we're able to manage the sagging associated with ice on the conductor. And number two, the conductor is strong. So it is able to handle the heavy ice on the conductor. And number three, if a utility would like to do de-icing on the conductor, with TS conductor, you can jack high current through the TS conductor. And for the portions you have ice, you can melt the ice. For the portion you don't have ice, you're not going to create what we call excessive sagging, or the conductor temperature will be high. And traditional conductor like ACSR, if you have a lot of ice, if you were to do fast ice melting by using large current, you cannot do that because the portion without ice, they're going to sag excessively beyond its limit. And you can only limit it to 90 degrees in conductor temperature. So you cannot put that much current into the conductor to melt the ice. So it will also help us to manage the ice related situation. And you mentioned about in the future, we expect that in the coming years, the conductor will be becoming smart. So we have technologies that we have been working for several years that we will be able to embed sensor material to allow the conductor, to allow the utility in the control room to know the precise condition of the conductor going forward, like temperature, like sagging, real sag information, versus in the past, all we have is dumb wires all these 100+ years. Society is becoming smart. Why shouldn't the power line be? Why shouldn't the grid, as well, build it from smart wires?
That would improve resilience.
Yes,
and maintenance.
across the board.
What role do you see TS Conductor playing in addressing the 2,600 gigawatt backlog of energy generation projects waiting to be connected to the grid that you recently highlighted?
Well, our role and our expectation is that the platform, it embodies the best you could do with science today to build a conductor. And the reason that we say make the statement is because there is no better material than carbon fiber composite as a strength member. It is lightweight, it is strong, and it is virtually no sag. Number two, in the aluminum, we feature the most conductive type of aluminum. Again, you wanted the more conductive metal in the conductor. Number three, the effective protection for the composite core, which was the vulnerability in the first generation advanced conductor. So with all that three combined, now you have the perfect package that we talked about. You deliver affordability, superior performance, as well as workability in the field. And that's why it should become the new standard in our industry for the coming centuries. If we can focus on doing that and making this product broadly available, we're doing a manufacturing expansion in South Carolina that will help us to support our industry. If we can focus on executing, then we're well positioned to make a contribution in transforming our power grid. Only when you have the power grid transformed with abundance in capacity, then can you consider accommodating and integrating all these renewable generations. Because without the grid bottleneck, without the grid in capacity, we're going nowhere, let alone energy.
Have secured significant awards like the DOE's Cable Prize and Platts Global Energy Award. What do these accolades mean to TS Conductor's market adoption? And what are the primary pathways you're pursuing to get this technology widely implemented by utilities?
Right. What I mentioned earlier is industry is notoriously conservative, risk averse. Having these industry recognition means a lot. And by the way, we're also invested by utility visionary leaders like National Grid, like NextEra, like Edison International, and Quanta Services because they mean a lot as well in terms of really vouching for our technology, and they're not only, they're also putting their money and investing in the success of the company. And what these awards mean is TS is innovative, but also a proven, mature technology that is real, that is able to help our industry. And so for that, we're very grateful. And it is also particularly meaningful for conservative utilities because they're always about risk. We're perceived risk. The more people that are embracing the technology, the less perceived risk that people would have because it's already being investigated, vetted, and verified by others. So it is a tremendous honor to receive these competitive awards, but at the same time, it has us significantly in this conservative industry. We relatively young, high growth company in the space. You could say that we've been growing at warp speed, but that's in the proper context of a very diverse customer base.
Any chance of partnering with Octopus Energy? They're pretty forward looking. They're in Texas and in many markets in Europe.
Yeah, they're more on the user end. I mean, the users, the electricity consumers, and we're more in the part. And I actually did have a conversation when I was in London for the Bloomberg event. Very engaging conversation. But at the same time, I think we have to focus on what we needed to do, which is ultimately it is about convincing more and more utilities and doing the adoption of TS technology at a faster, bigger scale. That be our focus because the basics is it's about overcoming reluctance of diverse culture and the conservative habit that it's not easy to change.
I hope Greg Abel is listening. Maybe he can move things quite fast for you. He's the new CEO of Berkshire Hathaway and Berkshire Energy, right?
Yeah, we will, Greg. We're also invested by Breakthrough Energy Venture by Bill Gates, and they don't invest in every companies.
And he's a friend of Warren Buffett. So maybe you can get him to get you in on with Greg Abel and Berkshire Energy.
I appreciate you bring that up, and I hope Greg is paying attention to this podcast. Thank you.
What are the biggest hurdles or challenges you encounter in bringing this innovative technology to market and achieving widespread adoption by utilities? Is it regulatory, financial, or industrial resistance to change?
I'll answer it in three parts. The first one, I already said, our industry being conservative, risk averse, they naturally do things, especially when it comes to the backbone technology, very slow, cautious. Number two is the policy side. The policy, the regulation really does not allow risk taking. And we also talked about there's lack of incentives for improving grid efficiency. When you have like TS, it can reduce line loss by as much as 50%. There's no incentive for the utility to make the grid more efficient by deploying like TS. The third one, people normally don't appreciate as much, but it's actually probably the most significant factor we had to address. That is the perception of TS conductor being also a carbon composite conductor, that the utility industry had very negative experiences in the past. That these conductors are delicate, difficult to work with, to break. What they do not realize is TS was developed precisely to solve those problems. And this is why when Lyman had a chance to work with our product, they form a completely different view based on their actual experience. And we actually have more customers adopting us because of the Lyman support, which is such a refreshing experience to have. Nevertheless, many utilities who don't know about TS and they all know about the first generation advanced conductors and they're gun shy, they make assumptions, and I blame them because those are painful lessons. All I ask is we're giving you a chance to hear us out and take our product, do a pilot if you're willing to do, first commercial. Also, talk to our existing other utilities that has been very successfully deploying TS. We've had no issues whatsoever. And that's something that the story to be told.
You've emphasized made in America. What is the strategic importance of domestic manufacturing for TS Conductor, and how does this contribute to national energy security and innovation leadership?
Yeah, there are many angles or aspects to this. In the US, you have two major suppliers, and the lead time from them, they're 52 weeks. It's very long. The advanced conductor area, there's even less option in terms of proven technology. And TS being all made in the US, and we do the manufacturing process under the same roof. We make the composite core from carbon fiber all the way to the conductor being stranded. It's the complete conductor, and they're all made in the US. That's important for some of the utility customers because there is the BABA requirement, which is made in them. Significant part of it is American made. So that's important. And it's important, the new tariff situation, that if it's not made in America, you have to pay a tariff. And that makes it tariff is a door. When you are American-made product that you try to export, then there are different challenges as well. But U.S. market is where there's significant activity into the. There's a need to meet the current needs from AI and data center build out. And we have a huge challenge. And if we can focus solving that, I think we're helping to make US more competitive in terms of AI, in terms of onshore manufacturing, because the power grid had to be addressed efficiently. We can do all these things that we needed to do to maintain competitiveness.
From your previous roles as CEO and CTO at CTC Global, you've experienced turning companies around and scaling technology. What key lessons from that experience are you applying at TS Conductor to drive growth and impact?
Right. That's a interesting question. Let me answer that. I would say the first one is I learned the industry is very conservative. By the way, I used to work in the aerospace. I thought getting a new material accepted by aircraft manufacturers, that's a challenge. Okay. That was an industry. But boy, was I wrong when I joined the utility space. It's a different level of conservatism. And so you have to have that patience. And number two, you have to be really realistic about what your technology can do and what are the limitations and what are the best opportunities. And I had to make major changes for that company strategy that they were developed economies. There were no market for them because there's bad reputation from product installation issues. Also, ice, cold weather region, the ice load sagging. And so I had to help that company in order to survive, basically move it to and prioritize it to the emerging economies in the hot climate region and really reconductoring because that's where they still had a chance. And that's how that company was able to make it out of bankruptcy that the company was able to survive. And humbly taught me that you have to have a product that checks all the box, especially Lyman. The Lyman bracement, a new technology into the T&D, the transmission and distribution space, is critical. Without that, it's going to be a very painful, slow process. And that aspect, critical implications to TS because safety is part of our six principal values. And we truly experience and the support of the Lymans, make it safe and easy to work with. That's of paramount value to our company and to the Lymans that will be working with our product.
Looking ahead, what is your long term vision for the world's power grids, and how do you see technologies like TS Conductor evolving to meet the demand of a fully decarbonized and electrified future?
Yeah, I would say that today the power grid, they seem to be the impediment to connect all the renewable generation to meet load AI and data center. We need to turn that around and make the grid the enabler for all of those things. And we have to, as society, as humanity. And I also expect that the grid in the future to be smart the way that everything else is becoming and start with the building block elements like the wire itself, that these wires are smart conductors, that they are able to report to the what's they're experiencing. If you have fires, a certain spot in the circuit is going to become warmer. And so you are able to know those things well ahead of time. And if you have extreme weather that are impacting the circuits, where it the intensity impact from those extreme weathers, and you'd be able to deploy resources much more effectively and efficiently as well. And you can also do what is called line rating, and it's not rating, it's a real time capacity management that the sag, the temperature, and basically maximize every circuit in terms of maximum allowed capacity safely from the room in the future.
What policy or incentives do you believe are most critical to accelerate grid modernization, and the adoption of advanced transmission technologies in the US and globally?
I think one of the ignored policy lever that will create transformational benefit is making the grid more efficient and recognize that economic benefit and the role the utility companies play. And if we make that an incentive, let's say you have line loss associated economic benefit, why don't we allow the utility to keep half of that economic value and then pass on the other half to the ratepayers? You're going to basically everyone from day one. And there's no subsidy here that we're talking about. And that type of policy, progressive policy, will wonders.
What role does collaboration with electric utility partners play in TS Conductor strategy, and how are you fostering those relationships to drive innovation?
Wonderful, right? We believe those are foundational for a company's success. And we already have that collaboration because four of our investors are already the incumbent utility players. As I mentioned, we have National Grid, we have NextEra, we have Quantum Services, we have Edison International, and they're all leaders in the industry. And we listen to their views, and the reason that we're doing capacity expansion largely is because of their strong encouragement that you got to move bigger and faster because our products are much needed, them and by our industry.
What advice would you give to other entrepreneurs and innovators who are developing foundational technologies for the clean energy transition, especially those dealing with complex legacy infrastructure?
Right. I think first you start with understanding the customer and understanding and appreciate the complexity and the has the potential impact. Number two, when you deal with legacy infrastructure and companies that are involved, things don't move as fast as you want it. So you have to have staying power, persistence, and strategic patience. If of the software type of mentality, not going to make it. And this is the hardest of the hard tech. And we did about utility customers being risk averse and slow. But at the same time, when your customer, they could be your best type of customers and they're loyal, they stay with you. So kind of like things, whenever you a coin, there are two sides to it. Be always mindful of both sides. And when you're a young company, you have to be resourceful. And industry normally is big enough. There are going to be progressives as well as laggards. Don't waste time on entities just not in there to move fast, right? Work with our progressive that are interested in difference, grounded in terms of knowing your customer and also fundamentally understand what problem you are solving and what your and is not. And sometimes as an entrepreneur, you wanted to be sort of solutions for all. No, that is not realistic. And you have to know what are the situations you have to say no, and what are the situations that you should be fun, and really stay at it. Become the best in the world in solving that problem. And that's the I've seen that you're going to be able to succeed in a marketplace like this.
Traction internationally from any utility abroad?
Yeah, I was just Brazil last week, and we're very excited about that market. And we were raised by our partners and also by utility companies in terms of their interest for our type of solution. And we understand it's going to take some time. And some of it is helped by timing because one of the utilities there had a major failure issue with a first generation composite conductor, which failed like after 7 years. Lying. I don't say too much about it, somebody's misfortune, somebody else's fortune, but that is precisely how TS technology was developed to address those concerns, to address those issues. And I hope that more utilities through your podcast become aware that is a different technology. It's a different product than the core conductor that they might have been experiencing in the past. TS was developed to solve all those handicaps that they unfortunately experienced in the past. And once they really take time to understand what TS is, they're going to be pleased with what we are able to offer.
Temperatures are increasing in many parts of the world. So hopefully you can help a lot of utilities in those regions, both extreme weather and temperatures increasing. Any calls from Spain or Portugal?
They're figuring out really, but whenever you have a massive failure like that, there are going to be consequential changes in many aspects of the grid. And what happened in Spain and Portugal, if we don't fix our grid bottleneck and all those issues, it might repeat in other countries. And as you said, temperature is rising. The load demand from society for electricity is rising at a dramatic rate. And our grid is still relying on century-old wire technology. And it will much money, too much time to build new lines. We have to be resourceful in terms of solving that problem. And you have a solution in TS today that is available, ready to be deployed to help you.
Absolutely. Well, Jason, your insights into the critical role of grid modernization and TS Conductor's groundbreaking work truly highlight how fundamental innovations are shaping the future of energy. Your dedication to electricity delivered better makes you a definitive clean titan.
Thank you very much, Ali. I really appreciate the opportunity. You are so thoroughly prepared with all these insightful questions. I just such a pleasure to speak with you. Thank you.
You're welcome. To our viewers, please subscribe to Clean Titans for more exclusive interviews with the entrepreneurs, scientists, and investors driving the clean energy revolution. Like this video, share your thoughts in the comments, and hit the notification bell so you don't miss our next episode. Let's power the future together.